In this video, we're going to talk about how we can use different active and passive techniques to scan and enumerate network hosts. Basically, what we want to know before we start looking into an environment in order to break into it, in order to hack it as either a hacker or a penetration tester, or even as a systems admin trying to figure out what components are in your environment, you want to know, well, what is there? What servers, what network devices, what desktops, what devices are on your network? And so we have to be able to do that in multiple different ways because some tools work a little bit better than others. Now we're going to start off by talking about some passive methods simply because passive methods oftentimes are less visible to possible security people. So if we wanted to say somewhat hidden, then this is the method that we would use. So we'll go ahead and we'll get started on that. I'm going to go ahead and connect into a virtual machine. Actually, before we get into the virtual machine, let's talk about our network environment. So this is our network environment. First thing you may notice is, yes, this is a Windows XP machine. Yes, this is Windows Server 2008 and 2003. Yes, they are older machines, but that doesn't mean that the tools and processes that we're doing are anywhere old. These are tried and true processes that still work today with the latest and greatest operating systems. So don't be fooled by the age. The tools and the processes that we're doing throughout all of these videos will be consistently valid. Worst case scenario, in some of the later videos when we're looking at actually hacking into these machines, we may use a different attack, basically a different name or number attack, but the attack will run exactly the same way. So let's go ahead and get started. I'm going to get started by logging into this backtrack machine right here. Now what's called backtrack in this picture, nowadays this would be referred to as Kali Linux. So let's go ahead and log into that. All right, let's see, root, tour, T-O-O-R in order to log into it. And then now I want a graphical user interface. So I'm going to type in start X in order to start the X interface or X Windows interface. With that done, I'm going to go up here to the top where I have the little terminal console, and I'm going to click on that to open up the terminal. I'm going to make this a little bit bigger so it's a little easier for us to see. See, Control Shift Plus. There we go. That's about right. So first thing we're going to look at is we're going to talk about passive scanning using TCP dump. Now, I guess the first question is, why would I use passive scanning? And it really comes down to, what am I doing and do I want people to know I'm doing something? So in this scenario, I'm right here, I'm this user on this computer, and I want to see what all is in my environment. Now, if I am in fact a malicious user, I don't know what's on here, and there may be some sort of an intrusion detection system that will identify unusual activities. So I want to sit on this machine and I want to passively view what information I might possibly find on the internal network before I do anything active so as to not give myself away. All right, so for that, we will use the TCP dump command. TCP dump, I'll just do a -help. And we'll see it gives me lots of information with regards to TCP dump. My screen looks a little ugly with regards to the output here, simply because I'm zoomed in. I made the text bigger and it kind of wraps around weird. Yours will look a little bit better, but basically these are all the options I can give it. They are in these square brackets, which oftentimes means that they are not required. Same thing with the B size and the C count. Pretty much all of these are not included, therefore I don't necessarily need to include those. So what I'm going to do, I'm just going to run TCP dump without any options. Just going to leave it as is and let it run. And we can see there, hey, you know what? you can get some verbose output, do a -v. That's kind of nice for it to tell me that. It's listening on Ethernet 0, which is a 10 meg. That's interesting. And is capturing 65,535 bytes, 64K worth of information. So what it's doing is it's just sitting there and it's listening for information. This would be kind of the traditional spy method of sitting in a corner office and just listening for somebody to say something. Maybe you have your headphones on so people think you're listening to something else, but you're not actually playing anything, and therefore you're listening to what people are saying around you. And we can see some traffic is coming in. That's kind of interesting. I'm actually going to hit Control-C. I'm going to cancel this just so we can look at the data. It says, yeah, 35 packets were found. Some of them were filtered and dropped. That's fine. We're not going to worry about that. Basically, let's go on up to the first packet. Oh, wow, there were a lot of packets there, weren't there? All right, so we'll go up to our first packet. The first output here is basically the time. So as you capture these packets, it captures the date and time, basically, of when it was captured, so that if you want to play this back, this information back, you can. It tells me which protocol it is. In this case, it's IP. What IP address it's coming from, 192.168.1.1. It specifically specifies the protocol that's happening, or the protocol that's being used over TCP. In this case, it's NetBIOS. So NetBIOS is being sent from 192.168.1.1 to 192.168.255, and then a little bit of details as far as what type of packet it is. All right, hey, as a hacker or as a penetration tester, this is some great information to get started. In fact, I'm going to open up a notepad and I'm going to start tracking some of this. Currently, we just saw that we have two IP addresses, 192.168.1.1, 192.168.1.255. Now, as a random guess, I am going to say that 192.168.1.1 is going to be a gateway. That's going to be my router. And I say that because, well, almost all companies put their router as the .1 address. Additionally, I see here I have 1.255. That is probably, so let me actually write that in there. Router 1.255. That is probably the broadcast. And again, that's a guess. I'm not entirely sure, but most people, if they use a .255 as the final octet of their address, means that that is going to be the broadcast address, and they wouldn't use it anywhere else. This information tells me some pretty good information. For instance, it tells me right now this network is composed of 192.168.1.0/24. It's a Class C network, and that is the size of that network. Awesome. All right. Let's look at the other IP addresses we have. Let's see. Here, a couple of seconds later, I have what's called an ARP request. ARP requests, if you remember back in your early days of learning about TCP/IP, an ARP request, an address resolution protocol, basically a machine has an IP address and it needs a MAC address in order to talk to. Therefore, ARP is what does the translation between an IP and a MAC. And that's what's happening here. Is it's saying, hey, who has this IP address? What's the MAC address associated with this IP? And when you find it out, go ahead and tell this person. So I just found another IP address, 192.168.1.50. I still don't know what it is, but I do have an IP address. Once that's done, once that communication is done, then I immediately get an ARP reply. So I did an ARP request, now there's an ARP reply, and it's saying, hey, you know what, 192.168, that's me over here, And here's my MAC address. Ooh, that's kind of interesting. So I could actually, in my notes, as I'm tracking all of this, I can actually start including in my MAC address. A8, A5, D7. Now I won't do the MAC addresses for all of them, but if this was a physical environment, this MAC address information right here could give me a lot of information. For instance, if this was a Cisco router, Cisco routers have specific what's called OUIs, or other words, the first three numbers in a MAC address specify the manufacturer. So now that I know what those first three numbers are, I could then look up to see what type of device this is. Is it a router? Is it a layer 3 switch? Is it a server? Is it a webcam? Is it, who knows? Now in this case, I actually know the 005056 is actually a VMware. That's a VMware virtual machine. So looking it up doesn't really help me. And I know that actually in this entire environment, it is all those. So I'm not going to keep tracking them for the other machines. But let's see, we can keep looking. Let's see, we have another IP packet going from 192.168.1.50, this time on port 33666, going down to 192.168.100.1. I've got traffic going to another network. Let's add that in. Actually, that'll be 192.168.100.1. Specifically says that this is domain type traffic. That might mean it's a domain controller. That's interesting. Not entirely sure. And then it references to a pointer address. This is DNS pointer addresses. So it would be 192.168.1.255. Again, probably a broadcast address. So let's just scroll through here. I won't go through all of those, but let's scroll through here, see if we can find other IP addresses. Got 1.50, 1.175. We'll want to capture that one. Let's see, are there other IP addresses? 1.1, 1.175, 175, 175. All right, so at first glance, these are all the IPs I saw. Now I did that really, really quick. I would actually be much more methodical if I was doing this for real, but we'll go with that for right now. So in theory, I've got a router, I've got a broadcast address, and then I've got 2 network devices and one I don't know. It's just another IP address. These 2 guys are probably they could be switches, they could be servers, they could be PCs, they could be cameras. I don't really know, but I do know that they're there, and that's the most important part. I know they're there and I can look for them. Not only do I know that they're there and I can look for them, they are hidden. I'm sorry, I am completely hidden. Nobody knows I'm listening to this. All right, so that is using TCP dump. And again, if I was doing this in a production environment or for real, I was looking for devices, I would run TCP dump for like an hour. And I would search through the output using something like grep or egrep in order to specifically look for those IP addresses and list them all out in a top-down method or assorted order to make sure I don't lose any of them. I would be much more concerned and specific with the traffic. So let's do the same thing, except let's look at doing another passive monitoring using Wireshark. Now for that, I'm going to log into a different machine here. Undock. In fact, the machine I'm going to log into is, back to our network diagram, I'm going to log into this Linux sniffer right here. What this Linux sniffer is basically it's a monitoring machine. A lot of companies will do this. They'll set up a sniffer and it will just have network adapters on multiple LANs, multiple networks, and then all the network adapters will be disabled until they're needed. That's basically what this guy is. It's a system out there. All of its network adapters are disabled, so we need to enable them to make it work. So let's go ahead and log in again. Root, tour, and then start X. Again, if you're using a modern version of Kali, it probably would go straight to the desktop, but we'll work with it for now. Go ahead and open up the terminal, and I'm going to make this a little bit bigger. Control Shift plus, no? Settings. Oops. Not sure what just happened there. Size? No. Font. There we go. What's going on? Font? Large. There we go. Okay. Made it a little bit bigger, just so that we can read it. All right, so now if we look at this machine, if I run ifconfig, if you're familiar with Linux, ifconfig, interface config, basically shows me the IP and interface information on the system. Here we can see I have one interface, which is LO, which stands for loopback. Basically, this is just the loopback. It's not an actual interface. We can see the address 127.0.0.1. That's the loopback interface. No IP addresses are on this machine. If, however, I do an ifconfig -A for all, this will give me all the interfaces, whether they are configured, whether they are online or not. And I can see I have an Ethernet 0, I have an Ethernet 1. Neither of them have IP addresses associated with them. And then I scroll down and I have my loopback 0. So that's, if we look back at our network diagram, that's the two interfaces right here. This is, I want to say ETH 0 or Ethernet 0, and then this is ETH 1. So what we want to do is we want to continue listening to our internal network, which means I need to take this guy and I need to turn him on. I don't need to give him an IP address. I just need to turn him on. So what I'm going to do is just use the command ifconfig ETH 0 up. And that turns it up. It turns it on. So now if I run ifconfig, I now see that I have two interfaces that are active. I have ETH 0, which is up and running, and LO 0, which is up and running. ETH 0 still doesn't have an IP address, which is perfectly fine. I don't want it to have an IP address. I want to simply, again, passively monitor what's happening in the environment. All right, so now I'm going to run Wireshark. So just type Wireshark from the command line. It gives me a little warning. Hey, this could be dangerous. Don't run this as root. In general, yeah, don't run this as root. I'm in a test lab. I know exactly what I'm doing. I'm going to say, don't show me again. And that's okay. Maximize that, make it a little bit bigger. So what we want to do is we want to start capturing. A couple of different ways we could do that. Probably the easiest, come up here to capture menu. And then say interfaces, and here we can specify which interface we want to capture from. There's ETH 0 is our first option. There's an any, which would capture from any interface. USB, or LO for loopback. Just for simplicity, I'm going to say ETH 0. and then say start. As soon as I click start, it does just that. It starts capturing packets, much in the same way that TCP dump did. So what's going to happen is if we wait a few seconds, this will start picking up various packets that are happening across the network. It's taking its sweet time, but they should just start showing up here in the list, at which point we could then look at them. These would not be super exciting because they would be exactly what we just saw with TCP dump. Basically, same thing, different point of view. I'm really surprised that was taking so long. There we go. DCP discover, that's interesting. Okay, so we've got some DHCP requests going on. This is very, very interesting. I am on the right interface. Yeah, ETH0, that is correct. Okay. Well, we'll let this start going as we're talking about it. So this is the same passive monitoring or the same passive enumeration that we did with TCP dump. It's a little bit easier for us to read in this format, us as humans to read in this format, but still is only a passive monitoring, which means we kind of have to sit around and wait for it to do its thing. I don't want to sit around and wait for it to do its thing. I want to be a little bit quicker about it. And we can definitely do that. Let's see, we're seeing some IP addresses. 192.168.1, 200. Ooh. Hey, we're seeing some new IP addresses. 192.168.1. Yep, we already got that. 175, we got that. 200. And 100. All right. Yeah. So we can keep doing that. It is the way passive. It helps keep us hidden, makes so that nobody sees what's going on. However, we want to speed this up. Passive works. It's slow, but it doesn't always catch everything. There may be some situations where the machines aren't as chatty as what we're seeing right here. The machines just may not talk, and therefore we have to find some other way to talk to them. So let's go back to our internal machine, our internal backtrack machine. There we go. We're no longer running TCP dump. I want to use the command nmap. Nmap is a network management tool. Specifically, it stands for Network Mapper. It's a great systems administration tool. It helps you find what devices are on your network, what services are on your network. It helps you find open IPs, which ones are being used, which ones aren't. So we're going to go ahead and use Network Map, and we're going to do what's called a ping scan. So scan of P, lowercase s, capital P, and then the IP address is 192.168.1.star. Doesn't like my star. Okay. So what this will do is this will literally ping every single IP address from 192.168.1.1 to 1.2 to 1.3 to 1.4 all the way up to 1.255. Go ahead and hit enter and we'll see how this works. So it takes a few seconds because we are literally pinging 255 different IP addresses. But when it's done, it should spit out a nice little list of all the hosts, all the IPs that have responded. First one, 192.168.1.1. We'll look at our list here. We've got 1.1. Uh, 1.50, we've got 1.50. There we go. 1.100, we've got it. 1.175, 1.200. Looks like we got every single IP from the via passive scan we did via active scan. So this gave us a lot of information. One, it told us everybody that's responding to ping. Not necessarily everybody in the organization, but it tells me everybody who is responding to ping properly. I now have an IP address for those guys right there. Because I saw 255 previously in my passive scan, but not in my active, that tells me that that is in fact a loopback, not a loopback, a broadcast address. So I'm not going to include that in my possible targets for hacking or penetration testing. All right, let's go back to Wireshark. And I'm going to let this keep scanning. It's going to keep sniffing. But what I'm going to do is I'm going to put a filter in here. There's a lot of information we're seeing. For instance, there's like NBNS, Net BIOS Name Services. There's IGMP, there's DHCP. There's a lot of different types of traffic. I want to limit that down. And specifically, I just want to look for ARP traffic. So on the filter, I'm going to say ARP and hit enter. And that will show me all of the address resolution protocol traffic. And if I scroll up here a little bit, we'll notice that we have somewhat of a pattern that's going on in here. Scroll, scroll, scroll. Where's my .1? Let me go all the way up to the top. There we go. We start off with who has 192.168.1.1. Remember the whole address resolution protocol. Which MAC address has this IP? And so you broadcast out and you say, hey, everybody, who has the yellow highlighter? I need the yellow highlighter. And then Sally says, I have the yellow highlighter. You can have it when I'm done. It's the same kind of idea. It's the broadcast of an ARP request. As soon as that's done, we in fact see an ARP reply. But as soon as that's done, there's also who has 192.168.1.2 and 1.3 and 1.4 and 5 and 6 and 7, and it goes all the way down to all the possible IP addresses. That's what Nmap did. Isn't that kind of cool? Nmap went ahead and it pinged every single IP address in our environment in order to see if somebody was there. Now, if I was to do this manually, that would be a pain. I'd have to type ping 255 times to be able to ping all of those IP addresses just to see who was up and running. Nmap did it for me in one command, and it was a little boring, actually, waiting around for it to come back. All right. Hey, that's great. That's awesome. That's some pretty cool technology. But you know what? That command, nmap-p, with all of this output, it's kind of hard on my eyes. I don't like command line tools. Actually, I love command line tools personally. I love Nmap. I've worked with Nmap for decades now, to the point to where I don't like the GUI versions of it. But let's take this to the next level. Let's look, instead of Nmap, let's look at a tool called ZenMap, which is a graphical user interface for Nmap. It's basically the same thing. We give it a target, 192.168.1.0/24. We can give it a profile we want it to do. By default, it tries for an intent scan. By the way, if you're a hacker or a penetration tester and you're trying to stay low key and not completely visible, don't do an intense scan. It will be extremely obvious that somebody's there. Same thing with these other options, intense scan plus UDP, all TCP, no ping. Those are all very obvious. It kind of announces to the world that somebody is there. Ping scan, what we just did from the command line. Quick scan plus, regular scan, comprehensive. There's lots of different options here. And then when it's done, you can see the actual Nmap command right there. Out of curiosity, if I just choose a ping scan, The command line changed a little bit. SN, we did a SP. Yeah, the command lines changed a little bit, and this is actually an Nmap update that you need to know. You have to do the SM if you take the Pen Test Plus certification. So I'll put that back up to the intent scan, and I will say go ahead and scan. So this starts off doing exactly the same thing it just did. It's doing an IP scan across the entire network. When it's done, it will do a more intense scan on all of the devices on that network, or all of the devices that were discovered. So for instance, if I go back to the Linux sniffer, to my Wireshark machine here, and I scroll all the way to the bottom, we see that there are more ARP packets. In fact, let me get rid of my filter. Go all the way to the end. There we go. And now we can see lots and lots of packets going on. In fact, if I choose one specific IP, let's say this .150, IP.adder equal 192.168.1.50, enter. There we go. We can see that there's lots of traffic happening on various ports. Here we have 50504, down below 50505. Up above that, we have this one, 36750, 36750. Wow, lots of 36750. That's a lot of 36750. But basically, it's choosing it's choosing different ports, it's choosing different protocols and different applications as it's going along. We can look more specifically, instead of just for one IP address, we can actually look for tcp.flags.reset equal 1 and enter. And we will see tons and tons of reset packets that are all happening because of ZenMap querying all of these machines for various applications. Now we've got 1.200. I was looking at .50. I think .50 is actually the scanner. That's why I was seeing the same protocol over and over. Let's try 1.100. 1.100, yep, IMAP, 36750 again, Telnet, 6565, CM2, yeah, lots of different protocols of ports that are being attempted. Now, this probably isn't done, we'll check anyways. Yeah, it's still scanning. Is it? Yeah, I think it's still scanning because we're not seeing any hosts on the left-hand side yet. So that takes about 5 or 6 minutes, possibly more depending on your network and the speed of your environment or size of your environment. All right, so those are some of our traditional hacking tools. Now let's say I'm back in my environment here. I'm a wannabe hacker, but I don't have Kali. I for some reason can't bring Kali into the environment. I still want to find out what's in my environment. I still want to do some sort of a passive and active scan, but I'm stuck on a Windows machine. In this case, we'll use Windows XP. All this still works under Windows 10. Well, it turns out we can actually do this via Windows XP. Before I do that, let me go ahead and stop our capture here. And then I'm going to go ahead and I'm going to start another capture. I'm going to not save what's already there. There we go. And I'm doing this because I want to see what's going to happen when I start working on Windows. All right, so my Windows machine is right there. Go ahead and log in here as, who do I log in as? Hacker. All right, so from here, I'm going to use the Windows command line in order to find out what my environment looks like. So let's go ahead and open up the command prompt, make this a little bit bigger. Can I make the font bigger? Yes. All right. So hopefully this will be a little bit easier to use, to read, making bigger. What we're going to do here is we're going to use a built-in Windows command. This command has been around since literally Windows 3.1, and it is the net command. If I do a net /? This will give me a help about the net command, and it tells me, oh yeah, you can do a net accounts, net computer, net config, net continue, net file. There's lots of net commands I can do. What I want to do is I want to view all the computers on my network, so I'm going to do a net view. Now if I just do net view, it should show me all of the PCs that it can find in my environment, via, at least that it can find via NetBIOS. So this will only be the Windows machines. Now it's entirely possible that these machines were configured with firewalls that block ping and that block ARP requests. Not ARP requests, that minimize ARP requests. Therefore, these could be new machines I've never seen before. So I'm going to, as a hacker or a pen tester, I'm going to go ahead and write these guys down. I'm going to guess that last one, WinXP, is the machine I'm on, but that's a guess. I'm not really sure. So the netview command gave me a list of computer names. Hey, that's kind of interesting. What about my domain? What domain am I in? Or more specifically, what domains are available? If I do a netview /?, this gives me more details, more options that I can look for. For instance, I can look for specific computer names. I can look for a specific domain. And the domain is in square brackets. So that means that the domain name that I choose there, this domain here, square brackets, which means that part is optional. I can do a net view with a specific network name or a computer name as well. So I'm going to do the net view domain. So net view /domain. Just like that. Everything after that was optional, so I'm just going to leave it as is. And what this does is it looks around in NetBIOS and it says, hey, what NetBIOS domains are there? Or what NetBIOS workgroups are there? Well, it returned two. It returned a workgroup and an XYZ company. So I know, let's call this domains. I know that I have a workgroup. Most likely, it's a workgroup. But I also have something called XYZ company, which might be a domain. Now, as a penetration tester or as a hacker, this means that I have different things that I can attack. I can attack the individual computers. I can attack the IPs that were up above. I can attack the IPs up above. I could attack the MAC addresses if I really wanted to. I can attack the PCs with the names. And now I can also attack domains. That's kind of nice. Well, let's get a little bit more detail about these domains. Actually, there we go. Specifically, let's look into the XYZ company domain. Which of these machines, all these machines up here that I saw, which of those are in that domain? Again, the netview command comes in handy. I just up arrowed to repeat the same command that I had there. At the end of domain, I'm going to type : XYZ company. It's not case sensitive, so it should work uppercase or lowercase. You know, I say that it's not case sensitive, and then it takes forever. There we go. Yeah, it just took forever, and it freaked me out enough to think that I said that wrong. All right, so basically what we did was you said, hey, XYZ company domain, what computers are there in you? And in this case, it returned back one machine called server, and only one machine called server. That might mean something. So first off, my initial net view did not include that server machine, so that's a new machine that I can attack. Secondly, if XYZ company is a domain, and not just simply another workgroup in the environment, but if it is actually a separate domain, then that means one of the machines in that domain has to be a domain controller. At least one of the machines in that domain has to be a domain controller. Because only one machine got returned, that's most likely a domain controller. So as a penetration tester, that might be the machine I want to attack, because it would then have access to everything else. While I'm here, let's go ahead and do the same thing, except instead of XYZ company, let's do it for the work group. So up arrow, delete XYZ company, and type in work group. And again, this takes a couple of minutes, and I see my 4 different machines there. So firewall, firewall, FW, I'm assuming firewall. Student PC, Win file, and Win XP. So these are probably all of the Windows machines in my current environment. And I can now start seeing, as a penetration tester, what some of my possible attacks might be. While we're doing this, let's go ahead and let's look back at our packet filter or packet capture. There we go. Again, lots of different packet types that are being captured here. I want to look specifically for browser type traffic. So I'm going to go ahead and type in browser. The NetBIOS stuff that we were just talking about as far as finding domains, finding computers, this is all browser traffic. And let's see. So we've got our IP addresses. That's kind of nice. We've got information about what we're doing. Let's kind of scroll this in. Let's see, local master announcement for server. So the server machine is probably at 192.168.1.100. Ooh, I'm tying them together. Nice. 1.1 browser announcement for the work group. Okay, that's just announcements. Same thing with the XYZ company. 1.100 get backup list, get backup list, get backup list. Local announcement FW is on 1.1. Oh, the machine FW that we've been seeing has our IP address of 192.168.1.1. That's interesting. So all this time, when we first started looking around here, we saw this IP address and we kind of guessed, and we're like, 1.1, that's probably our router. That's probably our gateway. Well, here we're seeing some information tying that together. Here we see, in Wireshark, we see the IP address and we see a machine name. So that kind of ties together the 1.1 with a machine name of FW. FW probably means firewall. So that might be a Windows machine running as a firewall that's at 1.1. That's some interesting information. See, we keep going. 1.200 is WinFile. 1.200 is win file. And I believe, if we really care to, we could actually look into these browser backups or browser requests. There we go. And we could actually look into the packets here. Get request, mail slot, browser protocol, SMB header. No, maybe not. I was thinking the browser information may be in here. Well, we do see here 1.175 is WinXP. All right, so it wasn't the full list I was looking for, but it does actually tell me my IP addresses. Lastly is just this pesky student student PC. BIOS. Yeah, my hope was that the get backup list. Oh, here's the response. Excuse me. There's the response. Does the response have the full list? If it does, I'm not seeing it. Let's see, 1.100 is server. We knew that, right? Yeah. Maybe that one. Yeah, I'm not seeing the backup list in there. Yeah. But basically, that does tell us a little bit about what our environment looks like as far as domains and our PCs, and we were able to tie that together with IP addresses. All right, one last step. Let's go ahead and let's look back at our Windows machine that we had started all of this from. There we go. We knew that we have all of this information, all of these machines, FW. I should be able to go ahead and ping that machine. One of the great things about NetBIOS is it does a name to IP mapping. So when I ping FW, it confirms the IP address for me. Next one, I'm not sure about this guy, so we'll skip it right now. Win file, 1.200, that's what I got. But WinXP, that's the local machine. So that's gonna give me weird information, that's fine. And then server, 1.100, that's what we expected. Lastly, let's try that student PC. Uh, 169.254, that's an PIPA address, which means it doesn't have an IP address. Not really sure what that means. Actually, if we look at our network diagram, that's not on there. And that's why I'm saying I'm not sure what it means and kind of ignoring it. Okay. Now that we've gone through all of that, we've worked with some very, very basic tools. Nmap, ZenMap, TCP dump, net, Wireshark, very simple tools that are pretty much everywhere out in the world today. Now let's get a little bit more detailed. Let's get a little bit more hackish. Hackish? Something like that. We're going to go back to our Kali machine here, this backtrack machine, and we're going to actually start using some hacker tools to continue our environment, or to continue what our monitoring of the system should be. Monitoring of the system. Identification of hosts in the systems. Okay, before I continue, there's my ZenMap. My ZenMap did finally complete. It does have a nice little GUI here. We can choose a host and then choose, you know, it tells me like what ports are open, what its topology is with other details. And yeah, it gives me lots of information. Again, I'm still a command line guy. I like command line better. So close that. And we'll clear this out. So what I'm going to do is I'm going to use a couple of hacking tools. One here built into my Kali machine, another one that's back on my XP machine. First one I'm going to do is called MSF console. This is the command line. It's also known as Metasploit. While this is loading, Metasploit is a management tool for hacking. Basically, what happens is as security vulnerabilities are found, security researchers build code to attack it. By building code to attack it and identify if the vulnerability is there, they're able to see if the vulnerability is actually resolved and how critical that vulnerability actually is. So I ran MSF console, took a few seconds to load up. It gave me a kind of a, yes, I know it looks ugly, banner message. It looks ugly because I'm zoomed in. If you like the banner message and you want to see another one, just go ahead and type in banner and it will give you another one. That's nice. That looks like I broke my machine, doesn't it? Yeah, that's the banner message. If I take banner again, I get another banner message. They're all kind of fun banner messages. So what I want to do is I want to continue my enumeration of systems in my environment. And for that, I'm going to have to use what Metasploit calls a scanner. So I want to find all the scanners that are on my machine. And for that, I use search, the search command, and I want to search for scanners. So search scanner and enter, and it will give me dozens, if not hundreds of scanners. Again, it looks ugly on my screen because I'm zoomed in. Hopefully it looks better on yours. But there's lots and lots of scanners. What I want to specifically do is I want to use an ARP scanner. Basically, I want to do an ARP sweep. I want to ARP every single device in my environment and scan it that way. So we can see the way that these are named. All the scanners, or at least most of the scanners, start with auxiliary, and then scanner, and then the name or type of the scanner, and then lastly the name. So the scanner I specifically want to do is I want to use the auxiliary, tab complete comes in handy sometimes, scanner of a discovery type, and then ARP underscore sweep. So I want to use the ARP sweep scanner. When I hit enter, I'll notice that my prompt changes. That just tells me, yes, I am in fact now using the ARP sweep scanner. All right, so some of the ways we work with Metasploit, it is a little unusual than what you might be used to, but at least it's consistent in its unusualness. So as you work with this more and more, it will become more and more obvious. What I'm going to do is I'm going to do a command called show options. I want to see all the options that might exist for the ARP sweep scanner. First option I can see is one called interface. There's not a current setting set for the interface. Interface is not a required option. If I leave it blank, this scanner will work without it. Then gives me a description, the name of the interface. So if I had multiple interfaces such as ETH0, ETH1, ETH2, I could specify which interface to use. The next one is rhosts. There's currently nothing set for rhosts. However, that setting is required before I can use this scanner. The description is the target address range. What range do I want to scan? Or a CIDR identifier. So I could do a range of like 1 to 10, or I could do a CIDR identifier of say a /24. Shost, again, current setting is blank, required is no. and this is the source IP address. SMAC, current setting empty, required no, and this is the source MAC address. So as I'm scanning, as I'm doing my scan and sweep, which IP and MAC address is it going to come from, and I can change those if I want to. Threads, current count is 1, required yes, and that is the maximum or the number of concurrent threads. How many parallel processes or parallel threads will I have doing this sweep? In this case, just 1. If this was a really large environment, I may increase that number to 2 or 10, depending on what seems to work the best. And then lastly, timeout, currently 5. It is required, and the description says that this is the number of seconds to wait for data to time out. So this is similar to like when you ping something. You send out a message to it, and you wait for a response. And this says how long we wait for that response. Okay, so now let's go ahead. We see that there are a couple of items, specifically one item that is required and currently has no value on it. So that's my rhosts. So I want to specify what my rhosts option is. So in the command, I'm going to type in set rhosts. Has to be uppercase. It has to match what's here. This is uppercase up here, therefore this has to be uppercase as well. So set rhosts space, and then I'm going to type in my 192.168.1.0/24 range and hit enter. All right, it shows me it set it. I can do show options again. And it shows me, yes, okay, you set it, it's good. We're set. Everything that has a yes has a value. Now we're ready to scan it. Before we do that though, let's look back at our sniffer. Let's cancel this and clear our filter. And then I want to capture again, just so we can see what happens as we start our scan. Let's see. So to start our scan, we just simply type run. And it starts an ARP sweep. It starts doing its equivalent of what we did with Nmap in order to find out what hosts are in our environment. While this is running, let's go back to our sniffer. And we can kind of see the same thing. Who has, and it is going one at a time. There we go, went all the way down to 255, so the scan should be done. Go back to our output and we can see 1.1, 1.100, 1.175, and 1.200. And it's just that simple. Yay, a whole bunch of ARP requests. So that was one way to be able to use Metasploit. We'll do one more in Metasploit. We'll go and we want to use a different tool, different than the ARP sweep. So we want to get out of the ARP sweep by just saying back. We'll see our prompt is no longer inside the ARP sweep tool. Now we can use a different tool. The tool we want to use is auxiliary scanner, in this case NetBIOS, and NB name. Just as before, I start off with show options, and I see what options are available and which options are required. Batch size, number of hosts to probe in each set. It's already set, that's great. C host, the local client address. Not set, not required. R hosts, the range hosts or CIDR identifier, not set, yes, required. Our port, the remote port, or what target we're going to be using for the remote port, that's TCP 137. That is a NetBIOS port. And then number of threads, in this case 1. Just as before, I have an rhost option here that I need to specify, so I'm going to do the exact same option that I did before. So set, again, all uppercase R hosts, 192.168.1.0/24. And when that's done, I could do a show options one more time, just to confirm I've got everything. And then lastly, run. So this will do a NetBIOS request to every single IP address in my environment. If we look back at our network scanner, we see lots of name query requests to different IP addresses. So it's using NetBIOS, a built-in Windows tool, in order to query all of these machines to see what is running on them, if they're running. We see right here, okay, 1.1. Hey, that's great. It's members of the firewall work group. Yep. 1.100, 1.175, 1.200. Great. Gives me lots of information, including the MAC address, what operating system it's running. Yeah, that's all really nice. All right, that's good for our Metasploit tool for right now. Let's look at one more machine or one more tool that's back on our Windows XP machine. In this case, we're going to be using a hacker tool called Kane. Yeah, some features won't work properly. That's fine. We'll ignore that one. So Kane is, well, it's a network attack tool, network discovery and attack tool that allows us to find the machines on our environment. So this is the last one that we're going to do. This time we're going to go up to on Kane. We're going to use the sniffer tab here. I'm going to go ahead and click on that. And then in the upper, on the tab above that, or the row above that, I guess, I'm going to click on the start and stop sniffer icon. It will prompt me and say, hey, which interface do you want to use? We can see here I have two interfaces, one with an IP address, one without an IP address. Shouldn't take a genius at this point to say, yeah, use the one with, because that seems to be working. So I'll stay with that. A few other options, start sniffer, start ARP. Don't use promiscuous. I'll leave those all as is and say OK. Once that's done, click Start Stop Sniffer one more time. And now it is sniffing in the environment. This will slowly start gathering information for devices in my environment. However, I want to be a little bit more active. I'm going to right click somewhere in the background here. Just say scan MAC addresses. Okay, what do I want to scan? Well, I could type in a range. I can manually type it in here. Or I could say, look at my subnet and figure it out. So it can figure it out on its own for me, which I'm going to go with and say, okay. Hey, ain't that great? It found my PCs, it found my MAC addresses. If I right click on one of these, I can say resolve hostname. And we'll see the host name show up right there, FW. Let's be able to find out exactly what the host name for my machines are. Host name. And if I don't like doing this one at a time, I could actually shift click in order to select multiples and resolve host name. 1.50, that's my Linux machine. That's my Linux Kali machine. It's not really running NetBIOS, so it doesn't really have a host name. That's why it's left blank. All right, so with all of that said, that is multiple different methods to do both active and passive scanning in our environment. We want to find out what hosts may exist in an environment. Which method you use really depends on one, how active you want to be, how proactive in your scan do you want to be, how obvious do you want to be. Two, what tools do you have at your disposal? Are you on Windows? Are you on Linux? Can you install hacking tools such as Kane or not? And then three, where you are. If you're inside the network, it makes it a whole lot easier to enumerate them. If you're outside the network, it makes it a little bit harder. So lots of different tools that we will be able to use all depending on the scenarios that we have before us.